Okay, so I made up my own problem here. Now, I want to know everything about this. I want to know the eccentricity, I want to know the directrix, and I want to know what kind of shape it makes, okay? Now, notice that we cannot make any decisions until there is a 1 here on the bottom left. That says 4. Turn it into a 1. So divide everything by 4. So this is what we get. So we have this here now. So I can quickly identify the value of E, because E is the coefficient of sine as soon as that's a 1. So here I can just look at this and I can say, hey, E is 3/4. It wouldn't be negative. It's just the number attached to it, 3/4. Now, because that's the case, because E is 3/4, that's the eccentricity. Since the eccentricity is less than 1, we are dealing with what kind of shape? We are dealing with an ellipse, okay? Furthermore, since this is sine, I know that my ellipse is going to open more up and down. If this were cosine, the ellipse would be more sideways. But since this is a sine, I know that my ellipse is going to be more vertically. It's just nice to know what to expect, okay? Now, I need you to tell me what K is. I need to know K. So what is K? To find that value, look at the numerator. The numerator is always called KE. So here, I know that KE is 21/4. The whole thing is KE. However, I know what E is. So let me take 3/4 for E and plug it in right there. So in order to get K alone, I can multiply both sides by the reciprocal. Now on a calculator, if you want, you would see that K is 7. So I know what K is. Why does that help us? Because they also want the directrix. Now for the directrix, I'm not sure if I mentioned it, but I'll say it again. For the directrix, if you have a cosine, the directrix would be x equals. But if you have a sine, your directrix would be y equals. Okay, so again, if your directrix, for cosine, it's x. For sine, it's y. Now, what's the number that you put here? Well, you got to tell me what K is. K was 7, so put the 7 here. However, keep this sign. Okay, so if this were positive, the directrix would be positive. If this is negative, the directrix is negative. Where do you get this number from? It's always K. Always, without exception. So the directrix, it's always K. Sometimes positive, sometimes negative. Sometimes X, sometimes Y. It just depends on the conditions that I just gave you. So as a summary, the directrix is there. The eccentricity is 3/4. And we are dealing with the ellipse. Okay? So the goal here is to write the equation of the conic in polar form that has these points as vertices. Now, right away, without delay, label this as r and theta. Label these as r and theta. Now, the most crucial aspect of this is to choose the correct formula. Because if you choose the incorrect one, we're taking L's all the way. So how do I know which of the 4 to choose? I would really make a quick sketch of this. So watch this here, okay? Check this out. Check this out. How do I plot this point? You open up theta and then you shoot out r. So let me position myself here in standard form. You always point out to the right. Now, I need you to move 3 pi over 2. 3 pi over 2 is about right here. Now, how much do I have to shoot out? 2 spaces. So let me go out 2 spaces. Boom, that's 1 point, okay? Now let's do the same for this one here. So let me reset myself. There I am. Now open up pi over 2 radians. Pi over 2, you're shooting in this direction. So how much should you go out? Well, that's the thing. You have to move 6 spaces. But instead of moving 6 spaces that way, you have to move 6 spaces this way because it's negative. So really, I'm going to go down 1, 2, 3, 4, 5, 6. And I'm going to put a point down there. So what would that be? 1, 2, 3, 4, 5, 6, like right here. So this problem actually comes out of your textbook. It's on page 618, number 28. I wanted to pick an even because I know you have to do the odds. And the directions tell us that this shape is a hyperbola. They give us that for free, okay? So we're looking at a hyperbola, and these are the vertices. So we know that it's going to be something like this, okay? But I don't want the picture. Darn it, I want the equation. But which one do I pick? Well, that's exactly why the picture helps. Because the graph opens vertically, I know that it's going to be one of the sines. If the graph had been horizontally, it would have been one of the cosines. But since it's vertically, it's going to be one of the sines. So that narrows it down halfway. Now, is it positive or is it negative? Here's how you make that decision. You see how the graph, it's more underneath the x-axis as opposed to above? So since the graph is more below the x-axis, it's more weighted below the x-axis, use the one that's negative. What would something for a positive have looked like? Something like this, watch, just bear with me. You see how that hyperbola, it's more pushed above instead of below. So for that one, I would have used this. But for ours, I'm going to use that. So I'm going to use this one here. Now, how do I actually fill it out? Well, look at the blue labels. That's r and theta. That's r and theta. Plug in r and theta, plug in r and theta into r and theta, and you'll have a system of equations. However, that system of equations can be solved very, very quickly if you follow these steps. So let me plug in r theta here, okay? So here's what we get. Okay, so this is the system of equations that we get. Now, think of the unit circle. What's sine of pi over 2? What's sine of 3 pi over 2? And fill in those numbers. That's what you should get because remember, sine of pi over 2 is 1. 1 times e is e. Sine of 3 pi over 2 is negative 1. Negative 1 times negative e is positive e. So this is what we get. Now here's what I'm going to do. I'm going to multiply both sides of this equation by 1 minus e. I'm going to multiply both sides of this equation by 1 plus e. Essentially, put this denominator there, put this denominator there. Let me continue my work down here. Okay, now maybe I can distribute this here, and I can distribute that there. Now please make one observation. Ke is equal to Ke. So if this is equal to this, that means this is equal to that by substitution. So here's what we have. We have negative 6 plus 6e equals 2 plus 2e. Solve that equation, and that'll tell you that e is, it looks like 8 divided by 4. It looks like it's 2, right? It looks like e is 2 if you solve that equation. Now, you can take e for 2 and plug it in here and plug it in there, but then you have to find k. Or you know what else you can do? Take 2 for e and plug it in only here. Don't plug it in there. Trust Lee for now. Take 2 for e and just plug it in here. That'll be 2 times 2, which is 4, plus 2 is 6. So notice that I didn't plug 2 in there because that puzzle piece, Ke, is exactly what I want in the numerator. So it's sort of a time saver, what I just recommended. So final answer, R equals, Ke is 6 over, the bottom should say 1 minus e, but what was e? E was 2 sine of theta. If you wanted to check your answer, you can go to Desmos. You can type this in, and it'll make that graph right there.